I am Olabisi, a Microsoft certified trainer and analyst. I also work as a data analysis coach at Techie Academy. In this video, I'm going to be teaching you data modeling in Power BI. And what you will be learning in this video are introduction to data modeling, why data modeling matters, relationships in data modeling, and schema. So what is data modeling? Data modeling is the process of defining and creating relationships between tables. So you might be wondering, oh, why do I need to create relationships between tables? So let's take, for example, that you want to work on an analysis that has to do with a data set that contains more than one table. So you have 2 tables, 3 tables, 4 tables, 5 tables, or more to work with for your analysis. How do you get insight from all of these tables without having to mess up your insights? This is where data modeling comes in. Data modeling helps you to create relationships between 2 or more tables. And when these relationships are created, it creates a linkage between the data that is stored in these tables. And basically, this helps Power BI to understand how your data tables are connected. And it helps you properly combine this data for proper analysis. Why data modeling matters? For easier reporting, better performance, and consistent insights. Like I already mentioned, you want to work with multiple tables and you want to be able to analyze or get insight from all of these tables at the same time together in one visual. What you need is to model the data to create a relationship between them. And this helps Power BI to understand that these tables are connected together, and it helps you to properly combine the data for your analysis. Now that we have learned what data modeling is, which is to create relationships between tables, what are the relationships in data modeling? Relationships in data modeling are basically created between 2 types of tables. Please note that I have bolding types, not 2 tables. While I was explaining what data modeling is, I said it helps you create relationships between tables, which could be 2, 3, 4, 5 more, or as required. Now, there are 2 types of tables that you need to create relationships between in data modeling. The first one is fact table. And what are fact table? Fact table contains numerical data. For example, your sales amount, the cost of product, the profits, quantity sold. It could also contain discounts if that was implemented in the sales. The second is dimension tables. And what dimension tables basically contain are descriptive data. For example, you have a customer table which is describing your customer. It is going to contain your customer name, gender, marital status. Now, you might be wondering, when I am working with a data set that has multiple tables, how do I identify which one is the fact? And how do I identify which one is the dimension table? Basically simple. All you have to do is look out for the table that has numerical data. And like I've stated the examples here, which of your table contains, for example, you're working with sales data set, which of your table contains the sales amount, which of your table contains cost, the profit, the quantity of products that was sold, and basically also including the products that was sold, or the customer that this product was sold to, or the region where it was sold. For dimension table, basically just look for tables that are describing. So you have a customer table. This is basically going to be describing the customer that the business has. Customer name, their gender, their age, marital status, their address, and every other information that customer has provided. Products table also. This is going to basically be describing what type of product does this business sell. Now that we have figured out how to identify the 2 types of tables that you need to create relationships between, how are these relationships created? How can we relate these two types of tables? That is where your primary and your foreign key comes in. The column that describes unique roles in a particular table is called primary key. When this primary key in a table is in another table, that column is called foreign key in the other table. So I'm going to give a practical example here. Like I've been using the example of a sales data set. Now you have a sales data set that contains customer table, product table, and the order table. Now, we are already able to figure that our customer table is a dimension table because, like I mentioned, it's describing the customers. Your product table is also a dimension table because it's what describing products. Now, the third table I mentioned, which is the order table, is your fact table because this is going to contain numerical data for the orders that were placed. What is the sales amount for the order that was placed? What is the cost of product? What is the profit? What is the quantity that was sold? What is the ID of the customer that this product was sold to? And what is the product ID that was actually sold? Now, if, for example, I want to relate a customer dimension table with the order table, I need the customer ID in the customer table because the customer ID in the customer table is basically uniquely describing a customer. Remember that I mentioned that your dimension table describes. So now you are trying to relate the dimension table customer with your fact table order. All you need to do is to look for the primary key in your dimension table. And in this case, it's going to be your customer ID because that is what's going to be uniquely describing each customer. And your primary key column cannot contain duplicates. There cannot be more than 2 customers registered in your customer table. Basically, every customer has to be uniquely identified by one customer ID. Now, this customer ID present in order table is a foreign key because what is it doing in the customer in the order table? It is basically pointing to which customer purchased or ordered which product. Now, the foreign key in the customer ID being a foreign key in the order table can actually be repeated. It does not have to be unique. It can contain duplicates. And this is because one customer can order multiple times. So now I have explained what fact table is, what dimension table is, and what primary and foreign key is. Now, just as a recap, your fact table contains numerical data, the dimension table contains descriptive data, and these are the 2 types of tables that we create relationships between in data modeling. Now, to create this relationship, I mentioned you need something to relate them together, which is the primary and the foreign key. And to identify your primary key, I mentioned that your primary key is the column that describe or uniquely describe rows in a particular table. And if that column that uniquely describes particular row in a table is present in another table, it is called a foreign key in that other table. And I gave the example of customer ID in the as a primary key in customer table being present in the order table. It is now a foreign key because in the customer table it is uniquely identifying the customers, while in the order table it is pointing to which customer has placed a particular order. Now, this is going to take me to types of relationships. I've learned what data modeling is, which is creating relationships. We have learned the types of tables that relationships can be created between, and we have learned what these relationships are based on, what I can use to create relationships between these 2 types of tables. Now, what are even the types of relationships that can be created between the 2 types of tables that we have learned about? There are 3 main types of relationships that can be created between tables in your data modeling in Power BI. The first one is one-to-one relationship. And this is when one record in a table corresponds to exactly one record in another table. So I'm going to give you a practical example here. So think of citizens and voters cards, where one citizen can only register 4 and as well also have only one voter's identification number. So now in a case where you're working with the citizen table and the voters registration table, you know that the citizen can only appear once in the citizen table because this is this is a table that is describing citizens. So a citizen can only appear once here. But also because for voters registration, one citizen cannot apply for or register for voters card more than once. This is also going to have the citizens details appearing only once in this table. So this creates a one-to-one relationship. Now, the second type of relationship is one-to-many relationship. And this is the most common type of relationship and also the most recommended. Here, one record in a table can match with many records in another table. And a practical example is a product table that contains one record for each product. Remember, I mentioned product table is a dimension table in the previous example I gave, because it is basically just listing out the products that the business have for sale, the products that they are selling. So now, a sales table which contains multiple records for every sale made of this product. So I want to work with these two tables, a product table and sales table. And product table is a table describing the product that the business have for sale. And sales table is basically the table that contains the numerical data of sales that have been made on the products that they are for sale. This type of relationship is going to be a one-to-many. And the reason why is because one product can be purchased multiple times. So one customer can come and buy one product. Another customer can come and say, I want that exact product. So you can have five sales made on just one particular product. And that is why the relationship between these two is one-to-many, where each product can appear in multiple sales. So I can order for one product and another customer would come and order for the same product that I've ordered for, and there are more customers ordering for the same product that I have ordered for. So the relationship between these two tables is going to be one-to-many, one on the product side because it is describing the product. And this cannot contain duplicates because one product can only be described one time in the product table, while in your sales table, it's going to be, a product can appear multiple times because one product can be ordered more than one time. Now, the third type of relationship is many-to-many relationship. And this relationship occurs when many records in one table relate to many records in another table. This relationship actually requires careful implementation because it is not usually recommended. It can introduce complexities in your reporting, such as ambiguous aggregation. So it's something that you would mostly want to avoid. But in a situation where you have to really work with this table, it is required that you create a bridge table to connect the two tables. And so this is what a bridge table will do for you. Let me explain this example first. In the case of students and courses, so you have one student that can enroll to many courses, and also one course can have many students enrolled, which it basically makes a lot of sense. But now, if I want to relate these two tables together, it's going to create a many-to-many relationship, which I've just mentioned can introduce ambiguous aggregation in your reporting, and you want to avoid it. So what you can do is introduce a bridge table. And in this case, your bridge table can now be enrollment, where you go ahead and combine what you have in both your student enrollment and course enrollment tables together to have your enrollment. And now you can use the student dimension table, which is describing students, and your courses dimension table, which is basically just listing out courses. It's just describing the courses that students can take, and this student table is just describing the students that the academy has, or maybe it is an institution. And this enrollment is now the table that is now containing both the courses that students are enrolled to, and the number of times the students can enroll to courses. Maybe one student has enrolled to 5 courses. That student's information is going to be appearing 5 times there. And if 5 students have enrolled to just one course, that course is also going to be appearing 5 times. So you have all your many appearing in your enrollment table, while you now have your unique roles identifying each student appearing in your student table, and unique roles for courses that students can enroll to appearing in your courses table. And now when you relate your student table to the enrollment table, it's going to be a one-to-many. And when you relate your courses to the enrollment table, it's going to be one-to-many. Now you have a bridge table that is carrying the many side, and you can relate your dimension students table and dimension courses table to this enrollment table. Now, I also want to explain what schema is before we go over to Power BI, where I will show us the practical example of how relationship works, or how you can relate your tables together in your model view in Power BI desktop. So now, schema. In Power BI, a schema represents the logical grouping of tables that are related to each other. So now you have learned that you need to relate tables together when working with multiple tables. You have learned the types of tables and what you can use to relate them, and the different relationships that can occur between these tables. Now, what structure do you need to define your relationship? Basically, this is what a schema is. It just defines the structure of the data and how this data is connected, related, and modeled. And we have 2 types. We have the star schema and we have the snowflake schema. What is a star schema? A star schema is a database structure where a central fact table is connected to multiple dimension tables in a star-like layout. I have an image here to display as an example. In this image, you will see that we have sales team table, location, customers, calendar table, product table, all related to orders table. Our orders table is our fact table because this contains numerical data, while all of these other tables surrounding it are dimension tables. The sales team is describing the teams that are in charge of sales. Your location is describing the location where sales have been made. Your customer is describing the customers that have ordered. Your calendar table is basically referencing dates so that you can use to point out to the dates that a product was bought, the month that maybe the month where the highest sales was made, and just for time intelligence analysis. Now your product table is describing the products that have been ordered. What are the products that this business sells? This is basically what your product table is going to be doing here. So now all of these are identified as dimension tables, like I have previously mentioned, while your orders table is identified as a fact table. Now, having all these dimension tables connected to one fact table in a star-like layout, like it has been arranged here, is basically what a star schema is. This structure of relationship that you have created between your dimension and your fact table is called star schema. Now, what is snowflake schema? A snowflake schema is an extension of star schema. So in a situation where some of your dimension tables have been further broken down into sub-dimension tables, this is going to create a more complex structure. So here, the type of schema that you're going to be working with for your data modeling is snowflake schema. So whenever you hear about snowflake schema, just know that snowflake schema is an extension of star schema. where you have some dimension tables that have been further broken down into sub-dimension tables. So now let's look at this example that I have here. We have our dimension products table here, our sales services table here, our currency dimension table here, customer dimension table here, and we have our fact internet sales table. This is our sales table, which is our fact table. But if you look further, we also have our calendar table here, which is also a dimension table here. But if you look further here, we have dimension product subcategory table and category table. And these two are an extension of your product table. So we have a table that is describing products. But now, this product table have also been further broken down into the product subcategory and products category. So what are the categories of products that the business sells, and what are also the subcategory of this category of products that they sell? So if you look carefully, these two tables are related together here, and they are both related to your product table. They are not directly related to your fact table. So this is basically what your snowflake schema looks like. It is when you have some dimension tables that have been broken down into sub-dimension table, and you have to relate those dimension tables to your dimension table, while your actual dimension table is related to your fact table. This creates a more complex structure. It's not just like the direct structure of star schema, where you know that you only have dimension tables that are all just related to one fact table, and that's it. Now, you also now have some other tables that are related to your dimension table, and your dimension table now being related to your fact table. So now I'm going to be heading to the Power BI interface, where we're going to be practicalizing all these things that I've explained for better understanding. For this practical session, I'm going to be working with a sales data. And in the sales data set I'm going to be working with contains 7 tables. And I'm going to be explaining better once I import this table into Power BI Desktop. I'm going to be explaining better how these 7 tables are going to be related. The ones that will be related as a star schema, and the ones that will be related with as a snowflake schema. Here, I'm going to click the drop down on Get Data. The data set I'm working with is an Excel workbook. So I'm going to be selecting the Excel workbook option under Get Data. And this is the sales data I'm working with. So I'm just going to connect to it to import my data. This should open up the navigator dialog box, where I can go ahead to select the tables that I want to work with. Like I mentioned, the sales table that I want to work with contains 7 the sales data I want to work with, contains 7 tables. And I'm going to be selecting everything because I want to work with this entire 7 tables. I'm going to be working with some of them to explain star schema to us, while I'm going to be using the other ones to explain the snowflake schema. I would directly just load this into Power BI Desktop because I am not going to be carrying out any cleaning. For the sake of this video, we're just focusing on data modeling. So I'll click on load, and this should load my data set into my Power BI Desktop environment. This is currently loading, so we're just going to give it some time. Now we have our data set loaded into Power BI Desktop environment, and I'm going to go to the model view. You can find the model view on the list of tabs on your left, on the left side of your screen. The first you'll find is the report view, followed by the table view, and the model view is the third one. So I'm going to click on the model view, where I can go ahead to model our data. So here I'm going to go ahead and minimize this interface so that we can see all the tables that we have. And one thing that Power BI will do for you is, once you import a data set that has more than one table, Power BI automatically detects and creates relationships between these tables. And to be honest, it does a good job at it. But there might be some cases where Power BI automatically picks some columns in relating this table and you do not want to use that particular column, it's okay for you to go ahead to edit this relationship and select whatever column that you would like to use in relating your tables. So here is what our table look like. We have I imported 7 tables. So let's go ahead to see if these are all the 7 tables here. 1, 2, 3, 4, 5, 6, and 7. We currently have all our 7 tables imported into Power BI Desktop, and we can see them on our model view here on this interface. So the first table we have is customer dimension table. We have currency, we have products, we have fact internet sales, we have sales territory, we have product subcategory, and we have product category. We can already identify these 2 tables as an extension of our product table. Remember when I was explaining snowflakes, I mentioned that the snowflake schema is basically the type of schema where some of your dimension table have been further broken down into sub-dimension table, which is going to introduce a more complex structure for your modeling. So here are the 2 extra tables that have been broken down from our product table. So we have our product table describing products, but now they are further broken down this product table into, we have products category as well, we have products subcategory as well, and we have product category as well. But for now, I'm going to be ignoring these 2 tables because the first thing I want to show us is a star schema. So I'm going to be moving them to the extreme, pretending like we do not have them, because I want to use this data set to explain both star schema and snowflake schema to us. So I pretended like our data set only contains dimension table and fact table. No further breakdown of any dimension table. So when you are working with a data set where there are no further breakdown of your dimension table, that data set is basically going to be modeled as a star schema. So in case you are wondering, how do I know if a data set I'm working with is going to be modeled as a star schema or a snowflake? Just look out for sub-dimension tables. Do you have any of your dimension table? It could be your customer table further broken down into sub-dimensions. It could also be your territory further broken down into sub-dimension. Maybe they try to break your territory dimension table into regions. This is the region territory for north, for south, for east, for west, and you have to relate all those other tables to this territory dimension table because they are an extension of this particular one. So in this data set that we're working with, the only dimension table that have been further broken down is the product. And for now, I have ignored those sub-dimension tables because I want to use this same data set to show us how a star schema works and how a snowflake schema works. So in a situation where the data set you are working with only contains fact table and dimension tables, then just know that when you are done modeling your data, the schema that you currently have is going to be a star schema. So whenever anyone asks you, what's the schema for your model? As long as it is just dimension tables and fact table that you have in that model, it is going to be star schema. So here we have our fact internet sales, which is our fact table. And you can see what Power BI already did. It detected the relationship between all these other dimension tables with this fact table, and it went ahead to automatically create this relationship between them. I can actually structure this however I want. So for me to structure them, you can just place your cursor on any of these tables and drag them. So here I am dragging the fact internet sales to be in the middle. I'm going to drag my territory table to be here. I'm going to bring down my products table. You can also collapse and expand. So here I'm going to zoom in again so that we can have a clearer view. So for me to expand, I can click here, I can click here to collapse, I can expand here, and if I want to collapse this again, I have to come here and collapse. So here is how you can structure. I can drag them. I'm going to drag my customer table closer and also collapse it. So now we want to see what are the type of relationship that Power BI have automatically created for us between this dimension and fact table. So I'm going to first show us the one for sales territory. For you to detect what type of relationship have been created, you can easily see that from this line that is linking this fact table to this dimension table. There is an asterisk on the fact table side, and there is a 1 on the dimension table side, which means that the many, this asterisk represents many, is on the fact table side, while the 1 is on the dimension table side. So you can easily, just by looking at the connection between them, just look for wherever your asterisk is and wherever your 1 is. Wherever your asterisk is the many side. Wherever your 1 is the 1 side. But for me to also further get insights into this relationship, I just have to click on the line that is linking them together, and I will expand my properties. And see, you can see the further description of the relationship that exists between these two tables. Here, the first table name is our fact internet sales, and it is showing us that the column that they have been related together is sales territory key. And the many is on our fact internet sales table. So this is displaying as many to 1 because the first table that is being displayed there has the many side, and the second table that is being displayed there has the 1 side. Many to 1, 1 to 1, they are basically the same thing. It just basically indicates, oh, what's your first table? Your first table is many, while your second table has the 1 side. If my sales territory table is the one that is displaying first here, this is going to appear as a 1 to many. So my cardinality is going to be 1 to many instead of many to 1. If my sales territory table is the one appearing as the first and my fact internet sales appearing as the second. So here they have been related to sales territory key. And here your sales territory key is a primary key in your dimension sales territory table because it is uniquely describing the territories that sales has been made. While your sales territory key here in your fact table is a foreign key. And here, there's your one territory key can appear multiple times because sales can be made in the same territory many times. So there can be 5 customers or 10 customers that stay in the same territory that have patronized the business. And here we have make this relationship active option. So in case you do not want this relationship to be active, you can toggle off this, make this relationship active. And once you make any changes to this relationship, you will have apply changes being active here. So if I make any changes and I do not click on apply changes here, this is not going to make any effect. There's not going to be any changes applied. But once I click on apply changes, this relationship is going to be inactive. So let me apply changes that I do not want this relationship to be active, and see, instead of the thick line that we're seeing between these two tables, it's going to now be a broken line being displayed between them, showing that this relationship is not active. So I'm going to make this relationship again by toggling this on, and I'm going to click on apply changes. But before I do that, there's also something called cross filter direction. So this is basically just showing the direction of filter for these two tables. And the most recommended one is to leave it as single. So this is basically saying that the cross filter direction is going in one direction from your one side to the many side. So here I'm going to click on apply changes, and the line connecting them, you see, it has already changed back to a thick line instead of the broken line that was displaying when I made the relationship inactive. We can also confirm relationship for other ones as well by clicking the related line between them. So for currency and fact table, We also have the many to one, and they have been related to the currency key and the currency key. And this relationship is active, and the cross filter direction is also single. Let's check for product. Yes, for product is also many to one. Our one side being on the product, and our many side being on our fact table, and this relationship is active, and the cross filter direction is single. So now you might be wondering, if Power BI has not created a relationship, it does not automatically detect relationship, and I want to be the one to create relationships between these two tables. How do I do it? So I'm going to first show us how to delete relationships. So for example, I want to delete a relationship between two tables. The first thing I will do is right click and on the line connecting them, and you will see the option for to either delete or to display the properties. So if I want to delete, I just have to click delete, and Power BI will display a pop-up to confirm if you truly want to delete this relationship, and I'm going to say yes. And so you can see these two tables are no longer related. I can do the same for my product and fact table as well. I can delete the relationship between them and say, no, I do not want this relationship to exist. So I've showed us how to delete relationship now, because I also want to show us how to create relationships by ourselves. So here we do not have any relationship between our territory table and fact table and our product and fact table. So now I have these two tables that I want to relate to my fact table. What do? I have to first find out what is the primary key in my product table and go and look for that primary key in the fact table that I want to relate it with. So here, I think I'll drag this up so that we can have a clearer view of what I want to do. So I'm going to just expand this, and I can scroll using the scroll bar right beside it. I can also expand this if I want to, I can drag it down if I also want to see or have more columns displayed. So here is what our fact internet sales look like. And let me do the same for our products table. Let me expand this, and then let's go ahead and look for our primary key. You can also go and look for your primary key by clicking the drop down. Look for the table on your data pane side, and then you can look through it to find which is your primary key. Or you can go to your table view here, and I'll click on dim products table, and I can look for whichever one is my primary key. So here you can see product key, product alternate key, product subcategory key, English name, and every other thing describing your product. Here we have identified product key column to be our primary key. So all we have to do is look for product key in our fact table. So here, when our product key here, this is our product key in our dimension table product, and we just have to go and look for product key in our fact table as well. So I'm going to scroll down gently. Okay, I found this, and all I have to do is I have to just drag the product key in my dimension table to the product key in my fact table. So here I'm going to drag and drop on the product key here, and see you are going to get a pop-up for your properties dialog box, where you can go ahead to edit your relationship or make any more adjustments as you please. So this is our product key from our product table, and it's displaying that it has been connected to our fact table, the product key in our fact table. Our cardinality is 1 to many, yes, and we want to leave it as that, because our first table displaying here is as to one side, and our second table displaying here as the many side, and our cross filter direction is going to be single, and we want to make this relationship active. All I have to do next is click save, and Power BI is going to create the relationship between these two tables. Can you see? They have been displayed here. So now another thing I want to do is I'm just going to go ahead and look for sales territory key here and relate it to sales territory key in our in our fact table, sorry. So I'm going to look for sales territory key here. Yes, this is it. So I will just drag the one here and place it on this, and our properties dialog box will pop up, and you can confirm if what you have selected is the sales territory key for both your dimension table and your fact table confirm your cardinality, your cross-filter direction, confirm if you want you have checked to make this relationship active, and click save. And here our relationship has been created. And so this is what your star schema looks like. I'm going to minimize this again. And here is what your star schema looks like. Your dimension table, all related to one fact table. Now, for us to implement a snowflake schema, I'm going to bring in back these two tables, which are sub-dimension of our products table. And what do I want to do now? I want to relate these two tables to my products table, because for these two tables also to be related to my entire model, I have to relate them to the dimension table that they have been broken down from, and they have been broken down from the product table. So all I have to do is look for which one of these two tables as the primary key that I can use to relate to the foreign key in my product table. So here I'm going to go back to my table view. My products table is currently highlighted, and I just have to look for the key that is a foreign key in my product table. So we have a product key column, which is a primary key. We have an alternate product key. We have product subcategory key, and we cannot find any other foreign key here, just product subcategory key, which means that we have to relate our subcategory table to our product table. So I'm going to drag this over here and move this backwards, because this is the one that I want to relate to our product key using the product subcategory key. So now I just have to look for the product subcategory key in our product subcategory table as well. And here I can click the table again, go to click on product subcategory key to display the columns that we have in it. And here we have product subcategory ID column, product category ID, and every other thing describing the product subcategory. And the first thing that we can see here is product subcategory ID. This is an ID, is stated as an ID here, but in our product table is stated as a key. If you want to confirm if these are the same thing, I'm going to go back to subcategory key, and I'm going to subcategory table, sorry. I'm going to click the drop down and check what are the distinct values that we have here. We have 37 distinct values, and I'm going to go back to product, click the drop down on subcategory key, and check what are the total distinct value that we have. This is currently scattered, but if we look through it to find what the highest number is here, what the highest value is here, it should be 37. So I'm going to carefully look through to confirm if the highest value, our distinct value here is 37. So yes, the highest I can find is 37, which means that these two columns are basically the same, but one is a foreign key in the other table and it is a primary key in the other one. So I'm going to come back to my model view, and I'm going to drag subcategory ID to subcategory key. Now that I've identified that subcategory ID is the primary key in subcategory table, while subcategory key is the foreign key of subcategory ID in products table. So I'm going to drag it and place it here, and this should show my properties dialog box where I can make further additions to my relationship or reference any other thing that I want to do in terms of cardinality and cross-filter direction. So here, product subcategory ID from our product subcategory table, which is a sub-dimension of product table, is being related to product table through subcategory ID and subcategory key. So here, confirming my cardinality to be one-to-many, cross-filter direction to be single, and I want to make this relationship active, I'm going to click on save. And now our model structure is no longer a star schema. It is now a snowflake schema. So when you are asked what schema did you use for your model, or what is the schema for your model, you can now say this is a snowflake schema, because now this is no longer just dimension tables being related to fact table, but we now also have sub-dimension tables being related to dimension tables that is now related to your fact table. And this brings us to the end of this video. I hope you have been able to learn something about data modeling, the types of tables that you can relate together in your data model, the type of relationships that you can create, the columns that these relationships are based on, and the structure that you can model your data in. Thank you so much, and I wish you happy learning. Bye.